Dear students, welcome to the topic cycloids. Today we will discuss about the cycloidal curves and their classification, the definition of a cycloid and the construction of a cycloid. Okay. Now moving on to the topic cycloidal group of curves. And these curves, when one curve rolls over the another curve without slipping or sliding, the path of any point of the rolling curve is called rolling. And when this rolling curve is a circle and the curve on which it rolls is a straight line or a circle, then we get a cycloid curve. That means if the rolling curve rolls over a straight line, we'll get one curve. If the circle rolling on another circle, we'll get one more curve. These are all curves are called cycloidal curves. Now these cycloid curves are classified, and the classification is the one is cycloid, the second one is epicycloid, and third one is hypocycloid. So in the today topic, we will get to know the construction of cycloid. First, we will learn what is the definition of cycloid. Then we will see the what is the construction procedure for the cycloid. Now the definition: cycloid is the locus of a point on the circumference of a rolling circle when it rolls over a straight line without slipping or sliding. Now here what actually we call them as when the circle is rolling over a straight line, this rolling circle is called the generator. The straight line on which the circle is rolling is called directing line. Now these are the terminologies we use. Now it's a circle. Now the circle which is rolls over the straight line is called the rolling circle, or it is also called generating circle because it generates the curve. That curve only we are calling as cycloid. Now this is a the blue line will indicate the straight line on which this circle rolls. So that's why the straight line is called directing line. Now the circle is rolling on the clockwise direction. If the circle rolls off the revolution, it comes to the midpoint of the straight line, and the point here I will put pointer here so that you will easily understand. This point for the off revolution, it reaches to the top position, and the next off revolution again it comes in contact with the straight line. Now connecting these all the points is a cycloid. So actually in order to draw this cycloid, these 3 points are not sufficient. We need to find out these intermediate points in between for the off revolution and the next off revolution. Now to draw, if you get all those points, if you can connect all the points, you will get the cycloid. Now we'll see one simple construction procedure for the construction of the cycloid. Now draw a cycloid. This is a problem statement. Draw the cycloid for one revolution of a rolling circle having diameter is 60 mm. So in order to draw the cycloid, we should have the diameter or radius of the circle and the length of the straight line. In certain problem statements, the length of the straight line will not be given. In that case, you need to consider only for one revolution because the length of the straight line is not given, so that if the circle is given with the radius or diameter, you need to draw the cycloid for only one revolution. For the one revolution, what will be the length of the straight line is? Length of the straight line is 2 pi r. You need to take the length of the straight line as 2 pi r. Now in this case, in this problem statement also, the length of the straight line is not given and the only diameter is given. That means you need to draw the cycloid only for the one revolution. Now the first step is drawing the cycloid with the 60 mm diameter, and this circle is rolling circle because this circle only rolls over the straight line to create the cycloid. And the clockwise direction we divide them into 12 equal parts, and we'll name them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in the anti-clockwise direction, and this green line indicates the directing line on which the straight line is. Now this the length of the straight line is equals to pi d because the diameter is given, so 6 into 3.14, that will be the length of the straight line, 2 pi r or pi d. Now we will divide this straight line into 12 equal parts, and at the end this straight line it reaches to the 12th position, so the points will change. Now we have drawn, we will move on. See, this is the locus of center line, because when the circle is rolling in the clockwise direction like this, the center will never change, it will be in the straight line only. Why? Because center to the circumference distance always same, and it is equals to radius. That means the straight line to the center always radius, so the locus of this center will be a straight line. Now we will divide this locus of center also 12 equal parts according to the, already we have divided this line, same points will be marked here, and you will mention them as C0, C1, C2, C3, C4, C5, so on up to C12. And after that, and you made all the circle into 12 equal parts and you named it 1 to 12. From each point you will draw the lines parallel to the straight line on which the circle is rolling. So you will draw all the lines parallel to the circle. Now what you will do is, the next step is to find the locus of the point in contact with the straight line. So now we are going to draw the cycloid for this problem, and to draw the cycloid we are taking the point on the circumference, this bottom point. So first thing in the cycloid problem, you need to find out which point you are going to draw the cycloid, whether the topmost point or the bottom point in the horizontal diameter right side point or horizontal diameter left side point. So depend upon that you need to take appropriate decision, because in the problem statement they will be clearly given on which point you need to draw the cycloid. So for us in this simple statement he is not mentioned to what point we have to draw the cycloid. So we are taking the bottommost point and which is in contact with the straight line. So after constructing all this, the next procedure is take compass and measure the radius of the circle and put C1 as center and cut the line passing through 1. Why? Because when the circle is rolling the clockwise direction over the straight line, we are making this entire journey, that means one revolution journey, into parts wise. That means when this circle will roll in the clockwise direction, this one in contact with one, and this point P to which we are going to draw the cycloid will rise up, and where it will rise up we have to find. That means how we will find means the center C0 will become C1 when this one in contact with one. So the center to this P distance will never change when the circle is rolling. So with that condition, we take the compass, measure the distance as radius, and put C1 as center, cut the line passing through 1, so that we will get a point which is called P1. Now again we will move this, again we will rotate the circle, the next stage, then the center C1 becomes C2 and 2 will contact with 2 here, so that the point P1 again rises. So again you will take the compass, measure the radius and put C2 as center, cut the line passing through 2, so that you will get the point P2. Next, when the center will come to C3, you will, with the radius you will cut the line passing through 3, so that you will get the P3 point. Next, with the C4 as center, with the radius you will cut the line passing through 4, so you will get the point P4. Next, P6, next C5 as center with radius, you will cut the line passing through 5. Next, C6 center, cut the line passing through 6. Here we won't need to directly, you can mark here because C6 is the center, exactly midpoint of this locus of center line. That means here when the C will become C6, that means the circle has already traveled half revolution. When it traveled half revolution, the bottom point becomes the top point. So directly at C6, you can draw a vertical line where it meets this top line. That point you can directly mark as P6. So when the circle again rotates, now it becomes clockwise direction. Now next time, whenever you need to cut, you need to cut on the right side only. So when the center becomes C7, you need to take radius of the circle and cut the line passing through 7. Next thing, when the center becomes C8, take the radius of the circle, cut the line passing through 8. Next, C9 as center, cut the line passing through 9. These 3 and 9 and center all are coincide. This locus of center line only, the line which is passing through 9 and the line which is passing through 3. That means when you are taking C9 as center, you need to cut the line passing through 9. So you will get P9. Next, C10, you need to cut the line passing through 10, and C11, you need to cut the line passing through 11. At C12, that means at the end of the locus of center line, that means the circle already rolled over one revolution. That means again the point when it is off revolution reaches the topmost position, and when it complete one revolution, it reaches the bottom position. So when you connect all these points, this yellow line is called the cycloid. So this is the locus of the point when the circle rolling over the straight line without slipping. Now, when the circle rolls over here, the point P changes from here. That means when it reaches to off revolution, it reaches to top. When again when it comes to end, it reaches to the bottom point. So when you connect all these locus points, you will get the cycloid. Now, to draw the tangent normal, so you need to find out a point on the cycloid where you need to draw the tangent normal. Normally in examination, they will provide with at a distance from the center, the distance from the straight line. For example, draw a tangent normal to the cycloid at a distance of 30 mm from the straight line. So from the straight line, you need to measure 30 mm on the cycloid, either left side or the right side. So you will get 2 points, either this side or this side. You need to choose, you take any one point. So for example, I am taking this S is the point for which we are going to draw the tangent normal. So in order to draw the tangent normal, so what first we need to find the point on the cycloid. After finding the point on the cycloid, we take the radius of the circle. So the radius of this rolling circle, in this case, the 30 mm will be the radius of rolling circle. With the 30 mm, you will cut the locus of the center line and you will mark this point. From this point, simply drop a vertical onto the straight line. So wherever it cut the straight line, mark this point, connect this point to the S to which we are going to draw the tangent normal, and this connecting line will become normal to the cycloid. And if you draw a perpendicular line to this normal to the cycloid at that point, then that perpendicular line will become tangent. So like this, you can construct the cycloid for one revolution or for 1.5 revolution or the 2 revolution or whatever the specific length of the straight line, because in certain cases they won't they will tell you that, for example, the diameter of circle is 60 mm, they will tell you to draw the cycloid only up to 100 mm length of the straight line, because 60 into 5 3.14 into 60 means almost 189 length of the straight line you will get here, but only 100 mm means, that means part of the cycloid only you will get. So up to that point only you need to draw the cycloid. It depends upon the problem statement. For example, if you take one more problem, one more different problem, what is this statement is a circle of diameter some is rolling on a horizontal surface by a half revolution, then it rolls up vertical surface, another half revolution, the point P at the bottom of the circle touching the floor, draw the bottom the point. So what is this statement is a circle with a diameter of 40 mm is rolling for half revolution on the horizontal surface, another half revolution on the vertical surface. That means you need to draw the half of the cycloid when the circle rolling over the horizontal surface, and the remaining half of the cycloid you need to draw when the circle rolls over the vertical surface. So for this problem, I'm first what I am doing is, because the problem diameter is given 40 mm, when entire one revolution, what is the length it will take is pi d. Now only for half revolution only along the horizontal line, so I am taking pi d by 2 on the horizontal floor, and the next pi d by 2 along the vertical floor. This what d by 2 indicates that when the circle at the exit at the end, so it will be at a distance of radius, so that's why I'm taking our radius from the pi, pi by pi d by 2, and here also from pi d by 2 only I'm considering it. Now here first we need to draw a circle of radius 40 mm. Now in this case, see, in the previous case when we see the construction of cycloid, we took 12 points on the, we divided the circle into 12 equal parts. Why we made is, when you divide the 12 equal parts, we divided the entire the rotation, one rotation, that is, or you can say one revolution, into 12 parts, so that you got the 12 points. You can easily connect all those 12 points. But here the case is, we are simplified because it is a complicated problem, so we simply simplified that. We made into only 8 parts, uh, and what you will get is, for the half revolution you will get up to C4 here, for the next half revolution from C4 to C8. So when the circle is rolling along the horizontal straight line, so when the C will become C1, you need to take the radius of circle, you need to cut the line passing through 1, and the next C2 you need to cut the line passing through 2. That means this locus of the center line only. Then when the C3 center, you need to cut the line, and you will get the P3 point, and C4 you will get here at the, because when it comes to C4, then half revolution is completed. That means the bottom point will become top point. When you draw the vertical line, this point itself the point P4. So for the next thing, so already you made here 4 parts. Now the remaining pi d by 2, because we divided the circle into 8 equal parts, you need to divide these lines also into 8 equal parts. For half revolution we made into 4 equal parts. The remaining half revolution you need to make 4 equal parts. So along the, this is locus of center line, and we made this fifth, sixth, seventh, eighth, the remaining 4 divisions on this. Then we will make locus of the center points also. We already completed C4, so this will be the C5, and this is C6, this C7, C8. So next thing is, what you have to do is, you already for C4 you already marked the point P4. So for C5, when this will become C5, what you have to do is take the radius of the circle passing through the line 5 here, the line 5. Why this 5 point came here means, when the circle rolls here, this point 8 point will become top and 4 point will become bottom. So here the 4, 3, 2, 1, this is 8. So this point is 5. So from the 5 also you got the line. So wherever the C5 center line will touch this line, it will become the species. So this will be the fifth one. So next, C6 center, you will cut the line. That means for the half revolution, it reaches here. So this will be the P6. The next thing is, this line, wherever it cuts again, this P7. So you will get the point here itself. So this 5 and 7 line. So this side you will get the point P5, C6. And next thing is P8 and the locus of the center line. So on this line only, this P8 point also there, you need to cut the line this 8 only. So you will get somewhere here. So by connecting all this point P1, P2, P3, P4 and P5, P6 and P7, P8. So you will get the curve like this. So if you draw the remaining curve, this red line. So here to here of evolution for the remaining of evolution from here to here. Like this, you can easily construct cycloid for whatever the conditions are given. Some because in some problems, what they will give you is the circle will roll for off evolution along the horizontal line and the remaining off evolution along some inclined portion of the line. So this will my end of the topic and thank you.